The car industry is going through one of its biggest shakeups in decades. And it all starts with a single, massive piece of metal. It's called megacasting, and it's a revolutionary process that is completely changing the very skeleton of the cars we drive. So, let's break it down. So, what's the big deal here? Okay, take a look at this. On the left, you've got the traditional way to build the back end of a car. It's this complex puzzle of about 70 different pieces that all have to be stamped, welded, and bolted together. Now look at the right. That's the mega casting way. It's the exact same structure, but it's made from one single massive die-cast part. That is a mind-blowing simplification. So the big question is, how on earth is it possible to go from 70 parts all the way down to just one? Well, that's what we're going to dive into. The technology that makes it happen, the new challenges it creates, and why car makers are betting big on this giant leap forward. Why would a company completely upend its manufacturing process like this? Well, the goals are seriously compelling. For one, casting one big part makes a car lighter, which is absolutely critical for electric vehicles. It slashes costs because you're getting rid of countless assembly steps. It makes the production line dramatically simpler. And you can create these really complex shapes that pack multiple functions right into the part itself. Now, this whole revolution isn't happening with hammers and wrenches. Nope. It's happening on a computer screen. Designers now have this incredible new toolkit. It's almost like they're working with digital clay, letting them sculpt these enormous, intricate components with a level of precision that was just unimaginable before. The first tool in that kit is something called topology optimization. Think of it like this. Designers basically tell a computer, all right, here's the space the part has to fit into, and here are all the forces it needs to handle. Then the software just goes to work, running thousands of simulations and basically carving away every single gram of material that isn't absolutely necessary for strength. What you're left with is the perfect, most efficient skeleton for the part. It's pretty amazing. And this is where it gets really interesting. The next tool doesn't come from the auto industry at all. It comes from filmmakers, from places like Pixar. It's called subdivision modeling, and it lets designers intuitively push, pull, and sculpt these complex organic shapes, just like a digital artist. This is totally essential for creating the fluid forms that make these megacast parts both super strong and actually manufacturable. So the new design process looks a little something like this. First, you're defining the physical space and all the loads the part needs to handle. Second, you run that topology optimization to find the ideal skeleton. Third, using subdivision modeling, designers turn that rough skeleton into a smooth, refined geometry that can actually be built. And finally, and this is key, they're constantly running simulations to make sure the part can be cast perfectly without any defects. An incredible technological shift like this, it's not just about the machines. It has a huge impact on the people, too. The sheer complexity of designing one part that does the job of 70 means the days of the lone wolf designer are pretty much over. Think about it. Back in the day, designing a single bracket or a stamped panel for a car was relatively straightforward. A lot of the time, one single designer could handle the whole process from start to finish. But for a megacast component? No way. It's just not feasible for one person. Now you need a whole team of at least 4 specialists, all working in super tight coordination. This shift really demands a whole new level of collaboration. So who's on this new dream team? Well, you'll typically have 2 designers who are focused purely on the shape and the function of the part itself. Then you need a specialist who designs what's called the gating and runner system. That's the complex network of channels that the molten aluminum flows through to fill the mold. And finally, you have a designer who's responsible for the massive die casting tool itself. So the big takeaway here is that the skill set has totally expanded. Deep technical expertise is still a must-have, but now organizational and communication skills are just as crucial. These designers have to coordinate their work seamlessly across different departments to make it all come together. Okay, as you can probably imagine, casting a single part the size of a small bathtub, well, it's not exactly easy. While the benefits are huge, this innovation creates a whole new set of massive engineering hurdles to overcome. So it's fair to ask, if this is so much better, what's the catch? Why isn't every car company doing this for every single part of the car? Well, it turns out the challenges are just as mega as the components themselves. The challenges are seriously significant. In tooling, you need brand new ways to manage the temperature and vacuums inside these enormous molds. For the process itself, the molten metal has to travel really long distances without cooling off. So that requires innovative ways to manage its flow. With materials, you need new aluminum alloys that are both incredibly strong and also highly castable, which is a tough balance. And finally, the massive dies themselves have to be designed for quick maintenance to keep that costly factory downtime to an absolute minimum. So, with all those massive challenges, you might be wondering, is this really worth all the trouble? For the automakers who are investing billions in this tech, the answer is a resounding yes. The payoff is just too big to ignore. This is what it's all about. Costs come way down, the final car is lighter, and the entire production process gets radically simplified. It even helps with sustainability by using material more efficiently and improving recyclability. But there's one more killer advantage that really changes the game. And that's speed, plain and simple. By focusing all your development, tooling, and logistics on one single component instead of 70, you can dramatically shorten the time it takes to get from an idea on a screen to a car rolling off the assembly line. And in the fast-paced auto industry, that is a massive competitive edge. So, what this all adds up to is just a smarter way to build. The process creates less waste, both in materials and in effort. It allows for stronger, more integrated structures, and the result for all of us is a more efficient, more robust, and just a better built car. And don't just take my word for it. Industry experts like Stefan Neer from Albert Huntman point out that this isn't some passing fad. Megacasting is really seen as a foundational, forward-looking technology that's going to continue to unlock huge potential for years to come. We are literally watching car manufacturing get reshaped in real time. But the final question is, where does it go from here? If you can cast massive, lightweight, and complex parts this efficiently, what industry is next? Aerospace? Construction? The possibilities are pretty fascinating to think about.